Hi guys, so today we'll be continuing with our study of quadratic functions, and we'll start with a summary of everything that we already know about them, okay? So to start with, what is the first thing we already know about them is that they look like this. Right? Where A, B, and C are constants. Okay? A, B, and C are constants. Those are the guys we identify the first in our function. Then we also know that we have a vertex. And then we can find the x-vertex from this equation. And this is also the axis of symmetry. So far, so good. This is what we've learned so far. Good. So we're good to go. We already know that we have to look into the A. So when we look into the A, we know we have a study of our parabola, okay? So if A is bigger than 0, it is a positive graph with the concavity upward, okay? And we also have over here a point of minimum. So my vertex is going to be a minimum. Now, if my A is smaller than 0, then it's going to be downward. It's a negative parabola. And we're going to have one point over here that is going to be the point of maximum. Okay, so far so good. Now, why do we need this? Why? Why would we study all this? Okay, so let's say that we have a situation like the one. I'm gonna pause the video so I can draw, and then I'll return the video when it's done, okay? Hold on. Hi guys, I'm back with the example. Alright, so one of the examples we could think of is, for example, in football. When they play football, and by football I mean American football, there is one thing called hang time. Hang time is the total amount of time that the ball stays in the air before it lands again. So if we think of the situation that's happening, at first, what do we have? We have a ball that is stopped at the boy's hand, then he throws it, and not only does the velocity and the height of this ball increases, but also the line it describes in the air is a parabola. So in this case, it's velocity, it's height, and also its line, the line it describes the movement, can be represented as parabolas, okay? In this example here, I got one quadratic function that relates the height of the ball with the time. So if you throw the ball, what is the height after t seconds? So do you agree that the height goes up, 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 up? At some point it stops and it starts going down. So if we analyze the parabola, it is a negative parabola with a point of maximum. Therefore, this equation has to have a negative a. And it, in fact, it does. Okay? So this is one example that I got from your book. That is a very good example that shows you one application of quadratic functions. Another one was the ice skater, that in this case the movement itself is in a straight line, but her velocity would grow and then stops because the ice is holding her back. Okay, so basically her velocity starts in 0, it grows, gets to a maximum point, and then it goes back until her velocity is 0 again. So the speed, the velocity, and here the time. Okay, the velocity is 0 at some specific point, it grows to a maximum point, and then it starts decreasing again. All right, so also this equation would have a negative a. All right, but okay, now let's focus on this equation here for a second. So the football example, we have the function itself, and we know that we are relating height and time. Okay, so we could solve this doing the normal procedure, which is finding the vertex and then just guessing numbers. But what if I didn't want to guess? What if I wanted to know what the roots of these equation are? Okay, so what are the roots? In our case, they're gonna be points where the graph cuts the x-axis. We call roots the points where the graph cuts the x-axis. So thinking of drawings, I'm gonna make a very quick sketch. So my roots would be this point over here and this point over here. How do I find them? How do I find them? So that is what we are learning today. I'll give you a hint. Guessing is not gonna help you. We cannot guess anymore. For this, we're gonna use something that was named after Bhaskara, which was a mathematician. All right, we use the formula of Bhaskara, and Bhaskara again, it's a formula, so you're gonna have to memorize. You're gonna have to memorize it. Is there another way of doing it without memorizing? Unfortunately, there isn't. Okay, so basically, we're gonna have two things. I'll pause the video for a second and I'll be right back. Okay, so moving on, Bhaskara. It's also called the quadratic formula, especially in English. In Portuguese, we just use Bhaskara and that's okay. All right, we are totally fine with that. So there are gonna be some names and some formulas for you to memorize. So please don't freak out and focus on memorizing them because they're really useful. Okay. Basically, I'm not gonna show you where it comes from, all right? I'm just gonna show you how it works. So, when we're using Bhaskara, instead instead of guessing. What we're gonna do, to find these points over here where they cross the x-axis, do you agree that we don't have a y? It's not moving vertically, it's only moving horizontally. So in here, my point is something 0, and this point is also another something 0. Okay? So I know that for finding my roots, I'm looking for the points which y is gonna be 0. And again, because we have an axis of symmetry that cuts our parabola into similar parts, we're gonna have 2 points where my y is 0. Alright, so I just copied my equation, and now instead of guessing random numbers, I'm guessing y equals 0. Okay? So, instead of writing y, I'm gonna write 0. But instead of writing in front of it, I'm gonna write after it. Okay? What are you doing? Okay, so I just replaced my y by 0, which is what I have to do when I'm looking for the roots. Again, I have to replace my y by 0 when I'm looking for roots. So let's just put a reminder here. When looking for roots, y equals 0. Okay, we might need other things here. Reason why I'm leaving this open here, have some free space. Okay, moving on. Now what? You don't know what to do, because if there was just this t squared and this t wasn't here, you would put the 2 on the other side, you would divide and find the square root. Okay? If you didn't have this, wouldn't be a parabola, it would be a straight line, and you also know how to solve it. But when you have a number that's square and a number that's not square, a variable that's square, a variable that's not, what do you do? Oh my god, what do you do? Okay. So now is where the quadratic formula comes in. Don't freak out, just take a look at it. It's beautiful. Okay? It's very beautiful. I'm gonna write in a different color just to make your lives prettier. So, if I'm guessing, I'm not guessing, I'm saying that y is 0, then I'm looking for x. I'm looking for 2 values of x. Okay? So if I'm looking for values of x, I'm gonna call it x equals. Yay! That's it. Welcome, Bascara. This guy is the quadratic formula, also known as Bhaskara. Beautiful, isn't it? Oh my God, miss. Do I have to memorize that? Yes, you do. However, there is an easier way of writing it. Do you see this part in red? We call this part in red the discriminant. Okay? The discriminant is this little part, b squared minus 4ac. And we usually replace this by the Greek letter delta. Okay? So, in other words, we say that delta is b squared minus 4 times a times c. Okay? And then we could rewrite the quadratic function formula with x equals minus b square root of delta. Please notice that this is a lot similar to the x vertex, but it is not the x vertex. It's a different formula. Why is there a plus and a minus here? Oh my God, miss, do you hate us? I don't hate you. It is because every time I have a square root, because it's a square root, the original number could either be positive or negative. For example, let's think of the number. Let's open the parentheses here. Let's think of the square root of 4. If we get the square root and put it on the other side, it would be x squared equals 4. They're the same thing. Okay, they're opposite operations. So which numbers? And remember that x squared is the same as x times x equals 4. What number multiplied by itself is going to be 4? Yeah, 2. 2 times 2 is 4. Is that your only answer, or is there another? And that's where it gets beautiful. It could also be negative 2 times negative 2. It is also 4, right? Because negative with negative is going to be positive. 2 times 2, 4. Because we could have a positive and a negative number multiplied by itself and still getting the same result, this is the reason why we have the positive and the negative sign over here. Beautiful, isn't it? Okay, how do I do that, miss? I'm going to do the following. Instead of solving this guy, I'm going to solve an easier one, and then I'm going back to this problem and solve the problem. Okay? So